Hello class, welcome back. Today we're using what we've learned on surface area and volume to apply it with real-life problems. This is our 7th lesson in Unit 10. Let's begin by reviewing your homework from last night. The problem reads, Macy is using cubes that measures 1/2 inch on each side to fill a container that has a length of 5.5 inches, a height of 2.5 inches, and a width of 2 inches. How many 1/2 inch cubes will Macy need to fill the container? So create a plan for solving this problem, and how do you model this problem? I modeled this problem by doing the drawing out the larger container first and writing down the dimensions, and then drawing a smaller cube with 1/2 inches on each side. And I'm going to see how many 1/2 inch cubes are needed to fill this larger container. What is the volume of the container? Well, the volume is length times width times height. So I plugged in my units, my measurements, and then I multiplied them out, and the volume of this larger container is 27.5 cubic inches. And then the last question, how does the volume of the container relate to the number of 1/2 inch cubes it takes to fill the container? If you look at the measurements here, you can change them into 1/2 inch cubes. How many 1/2 inch cubes are in 2? And the answer, there are 4 halves that are in 2. How many halves are in 5 and 1/2? There are 11 halves. And how many halves are in 2 and 1/2? There are 5 halves. So now we can take 4 times 11 times 5. I did 4 times 11 times 5 to see how many 1/2 inch cubes can fill this container. 4 times 11 times 5 is equal to 220 cubes. The other way that you could solve this problem is by taking the volume of the larger container, taking the volume of the smaller container, the smaller cube, 1/2 times 1/2 times 1/2 is 1/8, and then dividing the two, and that will also give you 220 cubes. Now, before we move on to today's lesson, I need you to complete the Unit 10 Day 101 quick check. So answer the paper copy first, and then I want you to enter your answers online into Blackboard. And when you're done, you can proceed to today's lesson. Now today we're going to be talking about packing to perfection. If you ever go to the grocery store, you will see that there are all different size boxes. And you also see that there are different advertisements on each box. Well, different companies have to use surface area and volume to determine which box or which size box that they would like to use, and then the advertisement people have to determine where to put the advertisements on the packages, and then the grocery stores have to stock the shelves with the advertisements in front. So today we're going to be talking about all of this. So at this time, please turn to Packing to Perfection in your handout. Is there a relationship between surface area and volume? Can rectangular prisms with different dimensions have the same volume? Do rectangular prisms with the same volume have the same surface area? At this time, please take 24 snap cubes and imagine that each cube is a fancy chocolate candy. For shipping purposes, these candies need to be packaged in boxes that are rectangular prisms. Knowing the company only sells their candies in groups of 24, what are the possible dimensions for the boxes? So at this time, I would like for you to take your 24 pop cubes, make sure you have 24 of them, and you need to create rectangular prisms and record the length, the width, and the height. And then you need to find the surface area. Now, as you can see, there are going to be 1, 2, 3, 4, 5, 6 different combinations. So at this time, Please pause the video while you complete the 6 different combinations here and calculate the surface area. When you're ready to check your answers, press play. Now here are the different combinations that you could have. Now of course they don't have to be in the same order as mine, but just make sure you have all 6 of the combinations, and then your surface areas are correct. Now I would like for you to answer questions 1 and 2 on your own. Which of your packages required the least amount of material, the greatest amount of material, and why is the amount of material important? Think about the pictures that I showed you earlier at the grocery store, all the different packages. Why is the amount of material important? And number 2, what do you notice about the shape of the package with the smallest surface area? How about the package with the greatest surface area? So please pause the video while you answer these 2 questions. When you're ready to check your answer, press play. Now for number 1, the least amount of material would be the 2 by 3 by 4, and the most material would be the 24 by 1 by 1, and we looked at the surface area here. And why is the material important? Because it costs money for the amount of material or the boxes that you're going to use. So the more that you're going to have, the more expensive. The least amount of material will be the least expensive. And talking about the shape, the smallest is closer to a square and the largest is longest rectangle. Now before you go on to answer the next questions, pause the video and look at all the different packages there are, different ways in which people do advertisements, the amount of material it takes to fill these, and take a good look and then think about some of the packages that you've seen in your cupboard at home or in the grocery store. Now I would like for you to answer questions 3 through 7. This is what you're going to need to complete for homework as well. Now here are some reminders for tomorrow's lesson. I want you to look at the materials list for tomorrow's lesson and talk to your teacher about needing the following. You're going to need white paper, colored paper, tape, marshmallows, plate, cup, ruler. If you don't have a plate, that's fine. You can use a napkin. But make sure you have all of these materials ready for tomorrow's lesson. Have a great afternoon.